want to do. Okay, so this one here, these are some of the trigonometrical identities that are very important and very common. One is for sine, and the other one is for cos, and the other one is for tan. Very important. How do we expand? Actually, it is expansion, trigonometric expansion. How do we expand a trigonometric function of sine where we have sine plus sine? I mean where we have sine and two angles are added. These are two angles, by the way. This is angle A and this is angle B. So the expansion for this is sine of A, which is this one here, sine of A, then cos of B. If it is the expansion for sine, you begin with sine A, so it is sine A, then cos B, then plus. Now you began with sine A. When you add, you should now go to sine B and cos A, like that. That's how we deal with the one for sine. Begin with sine A, cos B, then plus. Now it will be cos A sine B. So you interchange like this. So sine A, cos B, plus sine B now, cos A. This trigonometric ratio is also given in the other logarithm table. The other logarithm tables, they are always there also. So you can always find them there. Now that is the one for sine. The one for subtraction, it is just the subtraction sign that will change here, but everything is still going to remain the same. So it will be sine A, cos B, then now minus. Remember, you began with sine A, so this time it will be sine B, cos A, the way it appears here, like that. Now, let us go for the one of cos. The one for cos is different from the one for sine, in that for cos, you begin with 2 cos. For cos, it is cos A, cos B, minus sine A, sine B. When it is plus for cos, then this side it becomes a minus. When it is plus for cos, then the sign will now become a minus. And when it is a minus for cos, the sign will now become a positive, as you can see. So that's how cos is different from sine. So for cos, it is cos A, cos B, minus sine A, sine B. Then when it is a minus, the sign will change to plus, and it will now be cos A, cos B, plus sine A, sine B. So these four are very, very important. From these four trigonometric functions, trigonometric identities, from these four trigonometric identities, we can get the one for tan. How do we get the one for tan? The one for tan, remember tan A is the same as sine A out of cos A. In other words, tan is sine out of cos. So if I want tan A plus B, it will be equal to sine A plus B. And this one should be the same, should be the same as this. then divide by cos. So tan is sine out of cos, and I think you know that. Now I expand using these identities. Sine A plus B, we have agreed that it will be sine A cos B plus now sine B cos A, which is this, divide by cos A cos B minus sine A sine B, which is the expansion for cos A here, for cos A plus cos B. And here we are. I think this is not a problem. Now, we divide through by cos A, cos B. Everything we divide by cos A, cos B. And that's what I'm doing here. When I divide sine A, when I divide sine A cos B out of cos A cos B is going to cancel. Cos B is going to cancel here. And if it cancels, I end up having sine A out of cos A, and the answer is tan A. Must say you have failed to catch time. Now, if I have sine B cos A divided by cos A cos B, I'm dividing through by cos A cos B, I'm getting my answer as, because cos A is still going to cancel, this one cancels with this, I mean with sine B out of cos B, which is tan B. And here cos A out of cos B, this one here, if I divide through by cos A cos B, definitely the cos A cancels and cos B cancels, so I have one, which is this. Then here sine A sine B, I divide through by cos A cos B, which is this. Definitely the what is cancelling? Nothing is cancelling, so I remain with sine A out of cos A, which is tan A, and sine B out of cos B, which is tan B. So this is the expansion for tan. Tan A plus B, this one, it will give you tan A plus tan B out of 1 minus tan A tan B. Now these identities are in the logarithm table, but it does no harm for you to know them in your head such that you can always save time. Now, there must be a question from Navuma, of course.
Yes, teacher, I am asking. Am I just supposed to cram this, that sine A plus B is equal to sine A cos B, yeah, like that?
Yes, this one will never change. It is a trigonometric identity. That's why it is given in the log table, in the log book. It will never change. It remains like that. Only that what you have to know, we can change where there is A, we put there like 2 theta, and where there is B, we put there like X. So where you just maintain where there is A, you put what is there. You get that? Like this. Otherwise, these ratios do not change. They remain the way they are. And even this one cannot change. It remains the way it is. Only that we can ask you to prove it. Like I have set for you a question here. From what you have been doing, I can say prove that tan A minus B is equal to tan A minus tan B out of 1 plus tan A tan B. So what will you have to do? Now this time you have to use this tan A minus B. It will be sin A minus B out of cos A minus B. Then you will expand and put there the expansion is like this. The expansion for A minus B is this, and the expansion for cos A minus B will be this one. Then after you divide by cos A, cos B, it will give you this exactly the way I want you to prove it. To bring you to that. So that one I have put it there for you as an assignment. I want you to prove it, and you can send it to my inbox. No problem with that. Martina is on and off. I don't know why.
Before you move on, I have a question.
Yes.
You say sin A plus B, and we are saying it's equal to sin A cos B. So where does the cos come from exactly?
Here. My friend, this is an identity. Just like Pythagoras theorem. You should not change it. That's why I'm calling it an identity. Like the difference of two squares. You get that?
Yes.
So when you expand sin A plus B, you begin with sin, then cos B. Because if you look in the one for cos also, you realize there is sin. So it is an identity, and they should not be changed. They should remain the way they are. They are called identities. That's why they are given to you in the logarithm table, such that you don't change them, such that in case you have forgotten, you go there and you don't use a different one, because if you use a different one, you'll be wrong. Marcy, any questions so far?
I don't have.
Hey, Marcy, for you don't have a question all the time.
I have no question.
And then when I give work, you don't do.
Me? So this time I'm going to do
it. That's laziness. Okay. Now, how will that help us? How will those trigonometric ratios help us? Double angle formula. Now, I have sin 2a. It means here where there was a plus b, instead I have a plus a. I hope you are getting me. So sin 2a, it means where there was b, I will put there a also. So I now have sin a plus a here. I now have sin a plus a. So what will the answer be? It will be sin a cos a, because where there is b, I have put there what? A. I hope you are getting me. It will be sin a cos a plus, now where there is b, I put there a, so it will be sin a cos a. And that's how it ends up becoming this. So it will be sin a, sin 2a will be sin a plus a, which will be sin a, then cos a plus, now I would have said sin b, but where there is b, there is a now, plus sin b, sin a, then cos a, like that. And it gives me, this one becomes the same as this. These two are the same. So it will be 2 sin a cos a. It will be 2 sin a cos a. Now, cos 2a will be the same as cos a plus a, but where there was cos 2b, you realize cos a plus b, our identity was cos a cos b, and this b minus sin a sin b. So it will now be cos A, because I have put here A where there is B, cos A, cos B minus sin A, sin B. And this is what it gives us. Yeah? It gives us cos 2A will be the same as cos A plus A, which is cos A, because here there is supposed to be B, but because it is 2A, I'll put there A. So cos A minus sin A, sin B. So it is now sin A, because these two are the same. These two are the same. So Martina, you have just come, but we said we have these identities which should not be changed. They remain the way they are. But when we substitute, and instead of putting A, and instead of putting B, we put A, the spell changes like that. Don't worry, I've been recording. You will watch the recording. So now, having known that cos A times cos A, it becomes cos squared A, and sin A times sin A, it becomes sin squared A. But you remember that cos squared A, from the other identity of cos squared A plus sin squared A equal to 1, cos squared A will be equal to 1 minus sin squared A. So when I carry this and I put it where there is cos squared A, I end up getting this. I hope you can see it. And the identity becomes now 1 minus 2 sin squared A. So from today and onwards, cos 2A is also the same as 1 minus 2 sin squared A. Now, also sin squared A will be the same as 1 minus cos squared A. So cos 2A, I'm substituting from here, cos 2A, where there is sin squared A, I'm going to carry 1 minus cos squared A, and I put it there. Here, where there is sin squared A, I put there its value, which is 1 minus cos squared A. And what does it give me? It gives me cos squared A, which is this, minus 1 minus cos squared A. When I open the bracket, this will be minus 1 plus cos squared A. Then when I get this cos squared A plus cos squared A, it gives me 2 cos squared A minus 1, which is this. So these two identities are very important, these two, because there is where they are going to help us. That's the reason why I've been giving them to you. Can I have a question before we go to the next thing? Nabu,
Chairman, I have no
you have no question. Who is this? Who is this?
Pardon?
Who is this?
Oh, this is Ruth.
Oh, of course, yes.
Chair, I have no question.
You have no question?
Yes.
Martina?
Yes, Chair.
You have been on and off. Do you have a question?
Yes, I'm stable now, but I've not. I don't know where we is this where we started from? I don't know.
No, we started from here, and good enough, I'm recording. You will be able to follow the recording. Yeah? So for now, just know this identity, that cos 2A is equal to 1 minus 2 sin squared A. which we are getting from here. And cos 2a is equal to 2 cos squared a minus 1. Let us do the example, then you will watch the recording. At least don't miss the example. So now from what you have been looking at, tan 2a is the same as tan a plus a. But we said tan a plus b is the same as tan a plus tan b. So that means here there is also a for tan 2a, and this will be tan a also, and this will be tan b. That's how it will end up becoming 2 tan a out of 1 minus tan squared a, because even this will be tan a, then this will be tan a. So that's how we are getting that one. Now, how does that help us? If I have an example like this one, I don't, many of you would get problems because this is cos 2a. This is cos 2a. You would have found some of you adding cos a plus cos 2a, and you say that it is cos 3x, which is wrong. This is 2x, and this is cos x. So when you see cos 2x, you have now to come and remember this identity that you have just seen, that cos 2a is the same as cos squared a minus sin squared a. And you carry this identity. That's why I have given it to you. You carry it and bring it here. So where there is cos 2x, I'm going to put there cos squared x minus sin squared x. I think you know now where it comes from our work here. Yes, it is here. Its expansion is here. Yes. So Martina, for now, you need to know that cos 2a is cos squared a minus sin squared a. Then when you know that, you are good to follow the example. So let us continue with our example. When we substitute cos 2x with cos squared x minus sin squared x, it now becomes cos x, which is this, plus cos squared x minus. Now remember also, when you look at this expression, almost everything is in cos. So I can express everything in terms of cos by removing this sin squared x, and I put there 1 minus cos squared x. That's what I have done here. And I now solve normally. This one times, it will be minus 1, then negative 1 times negative, it becomes a positive, and I think you can see that. Then when this one crosses, it becomes a negative, and we have minus 2. And there we are here. Now this expression of ours does not have factors. It does not have what? Factors. That's why I have resorted to using the quadratic formula. The quadratic formula is x is equal to negative b plus or minus b squared minus 4ac out of 2a. You can see it there. Where a is equal to 2. Let's say this is x squared, this is x. That becomes the quadratic expression. So a is equal to 2, b is equal to 1, and c is negative 2. This one. So cos x, which is x squared, if it was x squared, I would say x is equal to, but now it is cos squared x. So cos x is equal to, another way someone would have said, let cos x equal to y, and this will be y squared. So you'll be saying y is equal to negative b. Remember my b is 1, so it is negative 1 plus or minus root of b squared, which is 1 still, 1 minus 4 AC. My a is 2, and my c is negative 2. This is mathematics, and I think you have no problem with it. Out of 2a, 2 times 2, which is a, it is there. A is 2, and we have our thing like that. Yeah? So cos x, when you look at this, it becomes 1 plus 17 negative times the negative plus 16, and it becomes root 17 out of 4. From your calculator, when you get cos arc of this thing, you are going to get the answer. I don't know, are you still there? I think you are still there. My battery was threatening to go off. That's why it had gone off. But I think you are still there. We had reached here, and I was telling you that cos arc of this, you are going to get 38.7. And cos is positive because root of 17 is greater than 1. So cos is positive. It is in the first quadrant and the last quadrant. So we shall have 37 as one of the angles. Then this angle will be 360 minus 38.7, and here it is. Now, cos arc of this thing, remember it is going to be a negative. It gives you negative 1.28. But negative 1.28 does not lie in the range which we are given of 360 and 0. So we shall ignore that because it is not in the range. And that's where we shall end. So that is our thing. I wanted to teach you how you can convert this 2x, if it costs 2x, by applying the identity that we have looked at. We can now have a question if it is there.